Welcome to the PhysicsPlace, the place to learn about physics, and in this video I'm going to explain how you can work with forces on a slope. So for instance, if you have this picture, you see different kinds of forces because this box is on a slope, and I will show you in this video how you can draw these and how you can calculate with these. Also, like this, the skier is going downwards on a certain slope and these forces have certain effects on them, and it's important for you to know how to determine how big these forces are. Also, again, this bicycle, I will come to that later on in an example. First, we will start with this situation. We have a box standing on a slope of 0 degrees. So this is just the normal situation. We have a gravity downwards and the gravity is completely cancelled by the normal force, which is going upwards and it's exerted by this slope. So now the gravity is completely cancelled with the normal force going up. So the complete gravitational force is being stopped by the surface. So this box will be just stationary and standing there. Here we've put the box on a slope of 90 degrees. So now the complete gravitational force is not being stopped. There is no force stopping this one because the box is actually not pushing on this slope. So there is no normal force going out of this slope. So now none of the gravitational force is being stopped by the surface. And somewhere in the middle we have the slope. So now the gravitational force is not completely stopped by the slope, also not completely ignored, but partly stopped by the slope. So partly the slope will stop the gravitational force and the rest of it will be used for the box to slide down. So now part of the gravitational force is being stopped by the surface, and it's important for us to know exactly how big that part is. And of course that matters how much degrees the slope is. So the angle of the slope is important. Here the angle is 0, here the angle is 90, so between 0, which completely stopping it, and 90, which completely not stopping it, there is something else, and we have to find out how to determine that. So in this situation, we have the box on a slope, and the slope has a certain angle here, which we don't know, and an angle of 90 degrees here. And there's one force from which we know the direction, and that's the gravitational force. That one is always going downwards, and part of it will be used to slide down the slope, and part of it will be stopped by the slope. And we have to determine how large those parts are. Therefore, we need to resolve this one force into two forces. One parallel to the slope and one perpendicular to the slope, which will be stopped by the normal force. I already showed you in a previous video how to do this. First you have to draw a parallel line with this one, and it goes to the top of the tip of this arrow, and another one from this line also to the tip of the arrow. And now you can draw the forces, one parallel to the slope and one perpendicular to the slope. So this one force is actually split now in two forces, one used for the box to slide down and one used for to stop being stopped by the slope. And as you can see now, we have a triangle here, and this triangle is the same shape as the triangle here. So here we have the same triangle as there. So this, if this is for instance 17 degrees, then this one will also be 17 degrees. So that's the same shape. And that's very important because if you know the shape of this triangle, then you can use this trick to calculate the different lines here. You probably saw this with mathematics. If this is the first time, this will be a little bit difficult. But as you can see here with this rule, if you have the opposite side and you divide it by the adjacent, by the hypotenuse side, like here, then you have the sinus of the angle. If you have the adjacent side and you divide it by the hypotenuse side, then you have the cosinus of the angle. So with that, you can also use the forces. So let's first see these letters, if we can put them here. We have here the 90 degree angle, which one is here. So we have the adjacent one, this one, which is actually here because it's adjacent to the unknown angle and with the 90 degrees angle. So this one is the adjacent. This one is the hypotenuse. So I'm very bad at pronouncing that one, but it's this one actually. And this one is the opposite. So now let's see how we can call those forces. So first, this one is the gravitational force. So the hypotenuse is always the gravitational force. Then we have the opposite, which one is the gravitational force parallel to the slope. So that's actually this one here, which is the same as this one. And then we have the gravitational force, which is perpendicular. So this one is perpendicular to the gravitational force, not to the gravitational force, sorry, but to the slope. So this one is parallel to the slope, and this one is perpendicular to the slope. So we have this one force, and within it are these two forces. Now let's see what these two have in common. We have the h and the o here, so it's this equation. So if we divide this one with this one, then we have the sinus of the angle. So if we divide the force parallel to the slope with the gravitational force, so O divided by h, then we have the sinus of the angle here. If we rebuild this, we can rebuild it to look like this. So if we have the gravitational force and we multiply it by the sinus of the angle, so we multiply these two, just like 6 divided by 2 equals 3, so 2 and 3 you can multiply to get Fg parallel to the slope. So if you want to calculate the force parallel to the slope, this one, you need to multiply the gravitational force with the sinus of the angle of the slope. So with this calculation, you don't have to draw it, you can just calculate immediately what part of the gravitational force will be used to slide down, so for this arrow. In the same way, we can determine how to calculate this one if we have the gravitational force. So if we have the force perpendicular to the slope, which is A, and we have the h here, then we have to use this equation to calculate. So it will look like this. So the h here will be this force, of course, and the gravitational force will be down here, and we need the cosinus. So again, if we multiply those two here, then we have the force perpendicular to the slope equals the gravitational force times the cosinus of the angle. So now you know how to calculate either the force parallel to the slope or the force perpendicular to the slope if you have the gravitational constant. One you use the sinus and the other one you use the cosinus of this angle, which can be everything between 0 and 90 degrees. If you use this in a calculator, it's very important to put your calculator on degree. Don't put it on anything else. There are a few modes where you can put your calculator on. It has to be on degree. So now, just in words, this sign is the component of the gravitational force that is balanced by the normal force exerted by the surface. So that's this one, and it's being balanced by a force which is equally to the other side. So it's the normal force of the slope. This one means that it's the component parallel to the surface causing the object to slide. So you have to know what these symbols actually mean. So an example, we have a cyclist of a mass of 87 kilograms and he is cycling with a constant speed on a flat surface. Calculate the extra force he needs when cycling on a 17 degrees slope. So it will look like this. We have the gravitational force here, and this one we can resolve into a component which is stopped by the slope, so by the net force, normal force of the slope, and this one which is actually dragging him back, so he will need an extra force which is equal to this force. So we have to calculate the force parallel to the slope, and that will be the extra force he needs to continue with the same speed. So we already have the mass, which is 87 kilograms, and from that we can calculate the gravity. And we also have the angle, which is 17 degrees. So first we need to calculate the gravitational force. With this equation, the mass multiplied by 9.8. So we know that this one, the gravitational force, is 852.6 newtons. So now we need to calculate this one, which is parallel to the slope. And if you look at the triangle again, we already have the hypotenuse, and we now need to calculate the opposite. So we need this equation with the sinus. So we need to calculate the force parallel to the slope is the gravitational force times multiplied by the sinus of the angle. Again, the calculator needs to be on degree. So 852.6 multiplied by the sinus of 17, and that equals 249 newtons. So this arrow will be 249 newtons, and that's the force he will need extra to continue on with the same speed when going up this slope. Another example, a box with a mass of 5.7 kilograms is standing on a slope like this. Calculate the angle of the slope when the normal force on the box is 53 newtons. So we now do not know the angle, but we do know the normal force. So this is the gravitational force. This will be the part of the gravitational force perpendicular to the slope, and this one parallel to the slope, and this is the normal force. The normal force is 53 newtons, so this one is also 53 newtons. They are always equal. Well, we know the mass is 5.7 kilograms. We know the normal force, which is 53 newtons, which is equal to the force perpendicular to the surface. And we have to calculate the gravity, of course, which is the mass multiplied by 9.8. So 5.7 multiplied by 9.8 is 55.9 newtons, so that's the gravitational force. And now we can calculate the angle. I use this picture again. So we need to calculate the angle. We do have the hypotenuse, which is the gravitational force, and we have the adjacent, which is the force perpendicular to the slope. So we need to use this one with the cosinus. So it's this one, gravitational force multiplied with the cosinus of the angle is the force perpendicular to the slope. Now, as you can see, we have to rebuild this formula. We have to divide by the gravitational force, so then the perpendicular force divided by the gravitational force is the cosinus of the angle, and we have to get rid of the cosinus, and therefore we need to use the invert cosinus. You have to check your calculator how to use it. You have cosinus -1, and that's how to get rid of the cosinus, because we need the angle and not the cosinus of the angle. So it will look like this, 53, because that's the perpendicular force perpendicular to the slope, divided by 55.9, which is the gravitational force, and then the invert cosinus of that, and then we will have an angle of around 18.5 degrees. So this angle is 18.5 degrees. The last example, calculate the acceleration of a skier with a mass of 75 kilograms when sliding down the 30-degree slope. Ignore friction. So he's sliding down a slope and he will have an acceleration because of that. Well, first we have the gravitational force downwards, and we have a part of it which is being perpendicular to the slope, which is being stopped by the slope, and part here being used to accelerate. So we need to calculate this part. Well, we have his mass, 75 kilograms. We have the slope, which is 13 degrees, and we have to calculate the gravitational force first. So the mass multiplied by 9.8. So 75 multiplied by 9.8 is 735 newtons. And now we have to calculate this one. Well, if we look at this example again, we have the hypotenuse. We have to calculate the opposite. So we use this one with the sinus. So the gravitational force multiplied by the sinus of the angle equals the force parallel to the slope. Because of these two lines, it's parallel. We can use this equation. 735, because that was the gravitational force, times the multiplied by the sinus and then of the angle 13. Again, look out that your calculator is on degree, and then we have a force of 165 newtons. So this force is 165 newtons. With that, we can calculate the acceleration, and we use the second law of Newton with this equation. So the force equals the mass times the acceleration, and we have to calculate this acceleration. So we need to calculate the 3. So we have 6 divided by 2, or the force divided by the mass. So the force divided by the mass is the acceleration. Well, we know the force, we just calculated it. We know the mass because it's given in the question. So we divide 165 by 75, and we know that his acceleration will be 2.2 meters per second square. So now you used the forces on a slope to calculate the force forward, and that you use to calculate the acceleration of this skier. That's it. You should now know how to work with forces on a slope, how to draw them, and how to calculate with them. If you found this video helpful, please let me know by liking, and of course subscribe for more videos. Thanks for watching.